Hey everyone, so this is the second video in a series on processing thermal imagery, so in this case from Mavic 3 Enterprise drones from DJI. And so I thought I'd just start out by talking about some channel news. So I haven't published a video in I guess over a year now, so I thought I would be more active since it seems like people are getting a lot of help and useful information from these videos. So I can continue both the thermal imaging processing series and the other one on deep learning, among other ideas I have. So I plan to upload more videos over the coming year. Uh, and I'll just go over a bit about the background in the previous video since it's been a while. And in that video, I really just went into what the image format looks like for these drones and just some of the basics of processing them using RStudio. And so this entailed just going over what are the settings, what are the parameters that are needed, and then just running through how this script works. And finally, I finished by really just importing a few images into Pix4D and then showing how you would process the converted images into a basically a mosaic. And so in these previous videos, I had some comments basically asking questions about how this process worked, about the coding, and then I know some other issues as well. So it could be one of the main ones is that the RTK information wasn't being copied over during the conversion process. So if you look on the right there, you'll notice that there is 5 meters for the horizontal accuracy and 10 meters for the vertical accuracy. And now these drones, if you're using RTK, it should automatically read the file information and get the correct accuracy measurements for each of these. So I really wanted to try and resolve these issues as well as make it easier to use. So using exif, you have to have Perl installed on your computer, and to get all the dependencies installed for the RStudio script is a bit, it can be a bit annoying, especially if you want to give it to someone and they don't regularly use R or Perl. So it's not really a portable script or program, and it can be quite slow. So I thought I'd just try and improve and at the same time provide more information to people who are interested on working with these images and incorporating uh, this processing into their own workflows. So really how this script and how most of these scripts work, irrespective of language, is that you want to run a command, and so you would start out by running the DJI Thermal SDK, and so that is simply a command line uh, tool, and so this will just convert your the input image into a radiometric image where each pixel has a temperature value. And so you need a few parameters for this, like the humidity, temperature, distance above the ground, and I'll go over those more a bit later. But once you've gotten the raw file that this produces, you need to reshape it into the correct dimensions. So this file is missing all the GPS information and the parameters you would need to actually mosaic it in some remote sensing or photogrammetry software. So once you've done that, you can then copy over uh, these parameters to the final step. And so really I want to show a bit about what all this stuff looks like. So here is an example of a file that's been calibrated with the previous RStudio script. And so when we look at it in exif tool, we can see that it has a bit of information. So it could be the GPS position, the latitude and longitude, just some pixel information, and the image settings, drone, make and model. But if we look at the original image that came from the drone, we can see that there's a lot more information here. And this includes stuff like, importantly, the RTK information, which would be needed to get the correct and better processing in Pix4D. So what we can do is we can improve on copying the exif information as well as speeding up the processing. So I'll be demonstrating how this works in Python because I think Python's very easy for people to read as well as understand, and it's very popular in deep learning and remote sensing right now. So I figured I would just go over basically how you use it. So I copied over the command from the previous RStudio script on actually running the DJI SDK. So we'll be using this as a basis for step 1. And then for step 3, I've created this command which essentially runs the exif executable file and then uses tags from file. So this will copy basically all the tags from our original image from the drone to our processed tiff file. And so I'll be going over how you actually use these two commands. And we start out by basically just importing the libraries we need. So in this case, we need NumPy. And then we also need subprocess. So that's how we actually run the commands. So we need OS. No, not that. So we need image from pill. So in that case, pill is pillow, and that is a very common Python imaging library. So that allows us to manipulate the image to set it the correct shape and everything. So from subprocess, we actually need creating a window. So if you want to use this as part of a larger tool and you didn't want the command windows popping up, you would just use this and you can set them to just run in the background. So to start, I will just set my emissivity, humidity, distance, and reflection. So I'll just make up some numbers here. So if you were actually turning this into a program with a user interface, you'd likely want to make sure that someone couldn't type in invalid parameters. So in that case, it could be distances above 25 meters above the ground, which the SDK won't properly support. So then we need to type in the resolution of the image we want to configure. So in this case, it would be 512 by 640. So this drone also has an alternate mode, which is super resolution, where this could be 1280 by 1024. And so you would want to make sure that your program could properly read or configure this resolution sizes. And so next we're just going to put in our file names and properties. So I'll just put an output file name. Yeah, let's call it file name. Just stick with the wording. So I could just make it test.jpg. And then we need our original image that has not been converted or processed in any way. So that would be this tag right here. And so we just want to find where this is on the computer. With the correct slash. And so next we need the folder we want to actually save our new images to. So that's outdoor. And then we could just choose this folder here that I'm using as a test. And so now we need the location of the SDK. So that'd be right here, just to be sure. So you'd go into the folder, utility, bin, Windows, and then 64. So we'd copy the path. And we would copy the name, so it's this file right here. And now the location of the exif program. Okay, so now we need to actually configure how we get the output file name, so route and tiff out. So what we'll do is we'll just do a bit of playing with the strings here. So we could take input name, and so we want the file name that we want to actually name the outputs of both of these, and then we could just replace the JPEG. I think. So in this case, your file name could be captured from a command line setting or from that user puts into a UI. So that's why I've just structured it like this to make it easier for us to follow. So we've taken off the file extension here because we're putting on a new one for each of these steps down here. So we want one for the raw out, and so that will be our output folder. Then plus, yeah, we need a slash and then the input name. But we also need to add the correct extension on the end, so we'll put raw. And then we need one for the output tiff file that we'll create. And if I make a mistake here, this is my first time doing live coding for a video, so we got tiff there. And so now we're all ready to use the command for our first step. So in this, we run subprocess instead of call. It's actually run. And so instead of shell, we would put create no window. So creation flags, create no window. So now it'll run in the background. And if you didn't want it to do running in the background, you just wouldn't put this creation flag, so that would pop up the window. But I think most of the time you don't want to be spamming your computer with command windows. So now we have the converted temperature file on our computer, so we need to reshape it into the correct dimensions. So we can take a resolution, and if we wanted to say if this was input as part of another part in our program, in a larger program, then we could always extract the rows to look at them and the columns from this. So we can extract the rows and columns if you want to look at them individually or adjust them in any way. I don't think we would need to, but we could create another thing called binary data, and in this we want to go so numpy.from our file, so we're reading in our raw file into numpy. So this has to actually be our raw out, and our dtype should be float 32. But now we need to actually reshape it to be the correct size, because if we just went and not from string. There we go. So if we just went and printed this, we would see that, yeah, we would see that it's just one long line of image temperature values. So we need to go and do this. So reshape rows and columns. I don't think we need an extra brackets on it. Yes, we do. Okay, so now we can look at the shape again. And we can see that it's correctly 512 by 640. So that should be the correct shape of our original drone image. And now what we'll do is, so we have the data in NumPy, so we can put this into Pillow to actually save it as a TIFF file. So we will do so in the future, so in Pillow 13, I think, you won't need to put the mode in, but I'll put it in just because a lot of people are used to it when working with Pillow. So we are not working with RGB data, so it's just a single image band. And we can now save it. So save it to tiff out, which is the string we created up above. And now we can uncomment this tag here. And we can create again another sub-process. And within, yes, this is the correct command exif and the create no window. And finally, we can go and we can clean up some junk that this is going to produce. So it's already prompting me for removing the raw file, and it says tiff out. However, if you run exif tool in this way, sometimes it'll produce a copy of the original file before you've copied the tags over. So we don't need that, and it'll be called underscore original after the file name. So we can remove that as well, and this should produce us with a new file. So I can just take off the temporary one I just created there. Yeah. So in the future, you won't need to add this mode tag. And so now we have not only an image with converted to temperature values, but we have reshaped it to be the correct number of rows and columns, and it's now saved as a TIFF file, and then we've copied over all of the tags from the original file. And so this process here, it seems to me is much faster than running it through the RStudio workflow we had in the previous script. And so we can look at this test image just quickly in Saga, and we compare this to the original one, or the one we've produced before. So these two images should look identical if we add them to the map. Yeah, they should look identical, but one should contain all of the information that we need for the proper use in Pix4D or other mosaicing and photogrammetry tools. Yeah, so here it has the all the GPS information, the exif information, gimbal properties, the flight speeds. So this looks much better than before. So we can also go and combine this script here into a larger program if we wanted to. So up here, you'll notice that this looks pretty similar to what I just created. Hopefully I remembered everything properly, but we would go through the same process where we would take in these parameters from the user, and we could then process these strings. We can then go through and parse this out into the commands. Then we run the commands. This would be step 1. Step 2, where we put it in the right shape and output it as a tiff file. And now where we'd copy it over and then do some garbage collection at the end. So if we wanted to, we could try getting some parameters to display for the user before we actually go and read it all with exif, just by using Pillow's built-in exif tags. But as we'd find before, the exif tags that Pill can read aren't complete, so it isn't able to actually get the RTK and the other information. We have to do that still with using the exif tool executable. So we can just go and prompt that for the user, and then if we want to actually turn this into a UI, so it's much easier for a person to enter into batch process many different drone runs using this instead of typing in parameters each time and editing the script for the file paths and locations. We'd rather just click through it and do it like that. So we can use a Qt widget for that. I won't go over all of this in detail, as there's many great guides for just creating very simple Qt interfaces. I might do that in a future video. This is really just on going through the processing here and addressing just some better information on how you'd actually code the processing of a conversion program. So we could then go, and if we wanted a button to import a directory, we could do that, and on these are clicking it, we could then get the altitude, the number of images from the folder they select, and then we could use multi-processing. So it would set up one process per thread, and each thread would have one image. So for all the images, we would go through and just run the processing above. So each thread would do this for all of your images, and it would work through it much faster than the RStudio script we had before, just because we've cleaned up some of the inefficiencies. But this isn't a perfect script either. I could definitely improve it in the future. And yeah. And I think that's everything. If anyone has any additional comments or suggestions, feel free to let me know. I guess thank you for watching. I'll be doing more coding tutorials on different topics in the future. So some with Google Earth Engine, others with Python, deep learning. So I'm going to do a optimization using deep learning in ArcGIS Pro. So that should be coming up soon. Thank you for watching. See you guys later.